As you know, all of the things that we are doing in this chapter and everything with the mathematics of time value of money that you learned with Professor O'Dea can be done in Excel. And actually, in the real world, virtually everyone uses Excel to solve almost all financial problems and certainly all real estate financial problems. So with that in mind, I'd like to show you how we typically solve some major problems in Excel, particularly finding NPVs and IRRs, and we'll do this by way of an example. What I've got here is an example with a company called Lukoil. Lukoil is an oil company that develops, refines, and sells gasoline and other oil products. And they have a gas station in Manhattan at the corner of 10th Avenue and 24th Street, which they believe needs renovating. So they feel that this renovation, if they did it right at this instant, okay, would cost them $650,000, and then provide for the next 10 years, starting a year from now, end of year one, provide them with a net positive cash flow of $100,000 a year. And Lukoil believes that, based on many gas station renovations it's done in this country, that its opportunity cost of capital, or ROCC, for this kind of project is 8%. So what I'd like to do in Excel with you is find the NPV of this project, and I'd also like to look at the IRR of this project, although it's not stated here, and then answer the question, should Lukoil go ahead, and finally, why or why not. And to do that, we're going to jump into an Excel spreadsheet that shows information very much like this. So let's jump into the Excel right now. It is also available to you in Coursera. Okay, so as you can see, I've now jumped to the spreadsheet. This is in your spreadsheet, time value and DCF examples, to show you how we would go about solving this in the real world using Excel. So the first thing I've got here is for Lukoil. I've got their opportunity cost of capital up here, and I'm going to be working initially on finding the project's NPV. And what you want to do is you want to lay out the key items that you've got going here, and you want to have time zipping along here. In our case, years, could be months, could be quarters, doesn't matter. And then underneath the time row, we want to have the cash flow that happens at that time. So at t equals 0, beginning of project, Lukoil is going to have to spend $650,000, so I have that as a negative number. And then for the next 10 years, they think their net cash flow in is going to be $100,000, okay? So as we know, to compute the NPV of this project, we're going to have to take each cash flow and translate it back to its equivalent at t equals 0. And that way all the cash flows will be on an apples-to-apples basis. Once we've got them on apples-to-apples basis, we simply add them all up. Every cash flow for one player at a time, for one project at a time, we add them up. And if the NPV is positive, it's a go. And if it's negative or equal to 0, it's not a go. Okay, so I'm going to start with this $650,000 cash flow. So I've got that. I want the present value of it here in C10. So I'm going to say equal to C9, the cash flow itself, divided by 1 plus the opportunity cost of capital. And I'm going to lock that down, which on a PC is function F4. And that needs to be raised by the amount of time in years that's passed since the beginning of the project, which I have right up here. 0 time has passed in C8. Okay, so that's looking good. A cash flow at t equals 0 discounted back to t equals 0 should just be the cash flow itself. I think this is a pretty general formula, so I'm going to just drag it across all the way through to my 10th year. And always good to check, so I'm going to check my 10th year where I have the present value of this 10th year cash flow, the cash flow itself divided by 1 plus the opportunity cost of capital, quantity raised to the 10. So that's looking good. Another check here is if we have uniform cash flows up here, the more we discount them back, the smaller they should get, which is exactly what I'm seeing. So I'm pretty confident I've got these right. And now I've got them in this row all on an apples-to-apples basis. They're equivalent at t equals 0, and I can simply sum them up every cash flow for Lukoil involved with this project, including anything that comes in or out at t equals 0, and I get an NPV of 21, which looks great. Okay, so that would mean, just thinking ahead a little bit, they should go ahead with this project. Now let's see if the IRR for this project supports that conclusion. So down here, I want to find the project's IRR, and the way that this works is in lieu of having a sacrificial worker helping us with this, I'm going to take a guess at the IRR. Some guess, any guess, 10%, 5%, doesn't matter. I'd use a positive number, small percentage. And now using that guess for IRR, I want to discount back all of my cash flows to t equals 0. So I'm going to do the same thing I did up above. I'm going to lock in that guess for IRR, and I want to discount each cash flow by the appropriate number of years. I think that formula is good. I'll know better in a second. Looks good to me. Always check the last one. That looks good. Notice how they're all getting smaller as time goes on. That looks good too. And as with NPV, I want to sum these up. All of my cash flows, apples to apples basis, discounted to t equals 0. Okay. And the IRR method, as we know, and as repeated up here, says that the proper internal rate of return for this project is the internal rate of return that makes the project NPV equal to 0. Okay, so two ways to go ahead and solve this. One is if you have a sacrificial intern, sacrificial worker, you can tell them to keep playing with this IRR number, and you see how it every time I change the IRR, I'm changing the NPV, and you can tell them to do that until the sum of all the present values of all the cash flows is equal to 0. If you want to be a little bit sadistic about it, which I don't recommend, you could tell them to do that to get this equal to 0 to 14 significant figures. That'll keep them busy for a long time because Excel only works to 11 significant figures. But most of us don't have a sacrificial helper, a sacrificial intern to help us do this. So instead, we're going to use a tool in Excel to help us solve this. So let's put ourselves in the sum of the PVs cell, or the NPV cell, and let's go to Data, What If Analysis, Goal Seek. Okay, and we're going to say set cell, that NPV cell, to value of 0 by changing our guess at IRR. And you can see very, very quickly it converges to two significant figures, to 8.7%, and you can see all the significant figures there in the cell. Okay, so this should be working. IRR, when it works, when it's applicable, and we've talked about that a little bit, when it is and when it is not applicable. When it is applicable, which it clearly is in this case, it should lead to the same conclusion for a project that NPV does. And NPV greater than 0, clearly saying we should go ahead. IRR 8.7%, which is greater than their opportunity cost of capital, so that says go ahead as well. So I'm going to just put down here NPV greater than 0. And we can say that implies that we should go ahead, and down here I'll just say IRR greater than the opportunity cost of capital, and that also implies we should go ahead with the project. So that's how we typically compute things in Excel in the real world. So I strongly suggest you try this on your own and become comfortable and facile with it if you want to go on in real estate finance. Okay, so let's go back now to our slides and continue.